Very occasionally, we will want to rationalize a numerator, usually because it'll allow us to simplify in some other nice way. For the moment, you'll know that you need to rationalize a numerator because the instructions say rationalize the numerator. When it comes up later on, you'll know. So how do we rationalize the numerator? Well, by using exactly the same techniques that we used for the denominator, just looking at the numerator instead. So for example, suppose we want to rationalize the numerator in the expression 4th root x to the third over y squared. Just as if we wanted to rationalize the denominator, we'll start by splitting up the root, and then looking at the numerator now, we'll think, what do I have to multiply by so that I get a 4th root I can actually take? Right, well, here I have an x to the third. I need an x to the first. So I'll multiply my numerator and denominator each by a 4th root x to the first. And now when I actually carry out that multiplication, I have 4th root x to the 4th, which is x. And in my denominator I have 4th root x y squared. Right, notice, when I rationalized the numerator, I ended up with a radical in the denominator. This will almost always happen. Right? If I start out with a radical, I'll almost always end up with a radical somewhere. If I get rid of it in the numerator, it pops up in the denominator. If I get rid of it in the denominator, it pops up in the numerator. Now, because my goal was to have no radicals in the numerator, I will not now turn around and rationalize the denominator. I will simplify in any other way that I can, though, after I rationalize my numerator. Let me show you another example of this, and then I'll give you one to try. Suppose that we want to rationalize the numerator in this expression. Well, notice we have subtraction in our numerator. And in order to rationalize this, we would like to square both terms. So we have something in the form a minus b, and we want to get a squared minus b squared. And therefore we're going to multiply by a plus b. So in my numerator, I have root x plus h minus root x. In my denominator to begin with, I have an h. I want to multiply my numerator by root x plus h plus root x. Whatever I multiply my numerator by, I have to multiply my denominator by that same thing. So in the numerator, I'll get root x plus h all squared, so that'll be x plus h minus root x squared, so that's x. In my denominator I have h times this guy. Okay, now in my numerator I can subtract, and in my denominator I'm not distributing right now, for reasons that I hope are going to become clear in a moment. Namely, I have h as a common factor. So what I'm actually left with is just 1 over root x plus h plus root x. Again, I ended up with radicals in my denominator. That was my goal. If I were to now turn around and rationalize my denominator, I would actually get back to exactly the expression I started with. Okay, let me give you one to try. Rationalize the numerator in this expression. Pause the video and try this now. Okay, so we have addition in our numerator, and this term at least we want to cube. So we have something in the form a minus b. We want to cube things. If we want to cube things and we start with subtraction, we'll end up with subtraction. And so we'll multiply by a squared plus ab plus b squared. So we'll have cube root x squared plus cube root x times 2 plus 2 squared. And that'll be cube root x squared plus 2 cube root x plus 4. Okay. So we're multiplying our numerator by cube root x squared plus 2 cube root x plus 4. Whatever we multiply our numerator by, we have to multiply our denominator by the same thing. So cube root x squared plus 2 cube root x plus 4. So then in our numerator, we'll get cube root x cubed, that's x, minus 2 cubed, so that's minus 8. In our denominator, we've still got x minus 8 times that long thing. Oh, but now we see that common factor between numerator and denominator. So we're just left with cube root x squared plus 2 cube root x plus 4 in our denominator, and just left with 1 in our numerator. Notice what's happening here. In these last two examples, our original denominator happened to cancel out. And that's usually what we're hoping for when we go to rationalize a numerator. We're hoping for a situation where the original denominator will cancel out. This is one of those things that comes up very, very rarely, but we need to be aware that it's a thing when it does come up.